Okay guys, we're talking today about slope. Okay, you've heard the word slope before. It probably makes you think of downhill skiing or sledding or something like that. And it essentially is kind of, this is connected, okay? Slope in math is how steep the line is. It's a number we give or assign. The larger the number, the steeper the slope. Okay, when the slope is a positive number, that means that the graph is uphill, okay, is increasing. A negative slope runs downhill. And again, this is left to right when you're reading a graph. Just like you read words, like the word negative right here, I'm reading that from left to right, okay? You read a graph from left to right. So down underneath here, I want to draw a positive and a negative slope, okay? We don't have to draw anything like a specific slope, okay? Just positive. So start low and go high. That would be positive slope. And a negative slope would be starting high and going down. All right, now remember our finishing touches of arrows on each end. We don't have equations for these lines to label with, but at the bottom I'm going to label this as positive and negative. Okay, now slope is often represented as a fraction because when we're figuring out slope, the formula is a fraction. You can divide out the fraction and make a whole number or decimal answer, but we will be saving decimals for next chapter. And for whatever reason, it's represented by the letter M. M obviously is not the first letter of slope. Not sure why it's M, it just is. Okay. On this last graph, I want to draw a particular special situation. Okay, two special situations. All right, if I have uphill slope, those are positive numbers. If I have downhill slope, those are negative numbers. Well, what's between positives and negatives? 0, right. So a line that is not going uphill and not going downhill, we would consider that 0 slope. It's flat. Okay. On the flip side, if I have a line, I'm going to use the arrow tool. I don't know why I didn't think of this sooner. Okay, if I have a line, and let's say I start out with my line like this. Okay. And nope, I want to edit this. There we go. If I make it steeper, then my number's getting bigger. And even steeper, my number's getting bigger. And even steeper, my number's getting bigger and bigger and bigger and bigger. Well, there is no largest number for slope. So as this line becomes vertical, we don't have any such thing as a largest number. Our numbers go to infinity. So what we would probably say then is this line doesn't have a numerical slope at all. We can't assign it a number. So we say that the slope is undefined. It is undefined. All right? So a vertical line is undefined. I also want you to add these notes. If later on in the lesson I'm going to show you how to set up a slope formula, if you ever have the 0 come out on top and a number come out on the bottom, that would mean 0 slope. And if you ever have a number on top and a 0 on the bottom, that would be your undefined slope. Okay. You might also hear undefined slope referred to as no slope. And I guess I prefer the word undefined because no slope and 0 slope sound too similar to me and it'd be too easy to mix them up. So that's why I use the word undefined instead. It's fine to use either one, but I tend to use the word undefined more. Okay. We're skipping this slide for now. All right, so on your homework and in the notes, it includes talking about the M, which is what we're focused on today. It also talks about the letter B, and on your homework, B is represented by the letters YI. That refers to the y-intercept. And it's a very easy concept, and I'm actually going to save the y-intercept for tomorrow. And we're going to focus 100% today on just slope. So I have a picture of 3 pictures of some lines here, and we're going to figure out the value for the slope, which is the letter M. So we're not doing the letter B. If you are not Mrs. Andrews' student and you did the letter B here, I am sorry, but I'm not talking about that in my video. Okay, I will talk about that in tomorrow's video. Alright, so first of all, I can look at the pictures and determine whether they're positive or negative. If I start on the left-hand side of the graph and work my way across, I see that the graph is going down. So that would be a negative slope. I'll put a negative sign. We'll come back to this one. In this graph, the middle graph, we're going up. We're increasing. So that would be a positive. I don't need to write a sign for positive numbers. Okay, I'll just come back to that one. The last graph I have, if I start on the left, I am going down. This will also be a negative value. Okay, put fraction bars on each line. The slopes are represented by fractions. Okay, now this is a formula for slope when I am graphing. Rise over run. And honestly, the words are not mathematical, technical terms at all. Basically, the person who thought up rise over run, which is not me, by the way. I learned that when I was a kid too. Rise over run. I think they just tried to think of 2 words that both start with the same letter so that it'd be easy to remember. Okay, so here's how to interpret it. Here's what it means. Let's say I pick 2 dots along the line, and I'm going to connect them via the grid lines. In other words, I'm making a right triangle. I'm going to trace the grid line down and trace the grid line across. I'm going to make this a little bit bigger. Okay. What rise means is count how many boxes up and down that you just traced. I traced 1, 2, 3 boxes. So my rise would be 3. The run, just like you run side to side, okay, even the best runner, unless they can somehow defy gravity, cannot run and go up. Running only happens on the ground side to side. So it's 1 square on this side of the triangle, and that goes on the bottom. Okay, so my rise over my run, that's 3 over 1. Alright, now I picked those 2 dots. Would it be any different if I picked these 2 dots? Okay, does it matter which 2 dots you pick? So I've got 3 boxes here and 1 box here. So those 2 dots, that didn't matter. What if I got crazy and I went from this dot all the way down to the bottom dot? Okay, can the dots be far apart? Will you get the same answer or a different answer? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's 12 boxes. 1, 2, 3, 4. That's 4. Well, guys, is 12 over 4 the same thing as 3 over 1? Yes, they're the same. Those fractions are equivalent. If I simplified 12 over 4, I would get 3 over 1. Or if I divided 12 divided by 4 and 3 divided by 1, I would get 3 either way. So the moral of the story is it does not matter which 2 dots that you choose to connect for rise over run. However, if you pick 2 dots in a row, you may not have to simplify. It'll reduce your need to simplify. Okay? So let's go on to the middle drawing. Okay? We already determined that this slope was positive. It's going uphill. So I'm just going to pick 2 dots and connect them. Any 2. Okay? And the rise is how many boxes up and down, that's 2. And the run is how many boxes side to side, and that's 1. So our fraction is 2 over 1. I could also use the whole number answer of 2. Okay, just like on this one, the answer was -3 over 1. I could have said or -3. I could have just left it as a whole number. Okay, there will be times when the whole number is useful, and there will be times when the fraction is useful. And as we get further into this unit, you'll see that happening. All right, our last one, we already determined that it's negative because it's going downhill. So I'll pick a couple dots and connect them. All right, and our rise is 1, and our run is 4. Okay, now 1/4 stays a fraction. It can't be simplified. 1 divided by 4 is not 4. Okay, and that would be that. All right, again, I am not going to talk about B today, or on your homework it's referred to as yi or y-intercept. We will talk about that tomorrow. So on the front of your homework, when you're doing that, okay, first of all, on the front of your homework, I'm going to have you skip the first 5 problems. Okay, we're not going to do the first 5 problems at all. Okay, so we're going to start at number 6. And we're not doing the y-intercept at all. We will talk about that tomorrow. So the slope, I'm going to pick 2 dots, connect them. All right, this is uphill, so my slope is positive. Make my fraction bar. My rise is 3. 1, 2, 3. My run is 4. So I've got 3/4. Number 7, again, I'm not doing y-intercepts today. I'm going to connect 2 dots. I see that this line is running downhill, so I'll make a negative fraction bar. I've got 2 down and 2 across. So 2 over 2, guys, what does that technically reduce to? You can write it as -1 over 1 or simply -1. Either one of those is correct, but make sure that you don't leave -2 over 2 as your slope, because that's not simplified. And if we look at, I want to look specifically at 8 and 10. Guys, if you look back at the notes where we talked about, oh, here it is. Let's blow it up. We talked about here, flat lines have 0 slope, and vertical lines have undefined slope. So when we go to our homework, okay, number 8 is a vertical line, and our slope is undefined. You don't put a number there, you don't make a fraction, you don't do rise over run. Okay, if you tried to do rise over run, if I connected these 2 dots, doesn't even make a triangle. Okay, so my rise is 2, that's fine, but there is no run. Okay, and if I have a number over top of 0, you cannot divide by 0. That is against the laws of math. If you type in 2 divided by 0 on your calculator, if you don't believe me, 2 divided by 0 on any calculator is going to either say error or undefined, because you're not allowed to divide by 0 in mathematics. Okay, here's a horizontal line. Okay, horizontal line, not doing y-intercepts. Horizontal line, my slope is 0. Okay, because if I tried to do rise over run, again, I don't make a triangle, I don't have a rise. It does not go up or down. It does go side to side by 1. Okay, you can take nothing and divide it into one group. You just can't take a bunch of things and divide it into 0 groups. All right, that's a really weird concept. If you understand it, that's great, but if you don't, just remember you cannot divide by 0 if you have a vertical line that is an undefined slope. Okay, let's go back to our notes. All right, so the picture, you may not always have a picture to work from to do rise over run. So there's slope formula. Okay, slope formula, a formula is like a math recipe. If you don't follow it precisely, if you don't follow it correctly, you will not get the right answer. Just like if you're making cookies and the recipe calls for flour, and you decide that you're just going to skip that, it's not going to come out right. Or if you try to stick the dough in the oven before putting it on the cookie sheets, yeah, you're going to have a hot mess in your oven, literally. Okay? So a formula for math is very specific, and the slope formula is over here in my notes. Let me put a box around it here. This is your slope formula. What it says is the slope is equal to a big long fraction with a subtraction sign on top and a subtraction sign on the bottom. It says if you take the y values and subtract those on top and the x values and you subtract those on the bottom, you've made your fraction slope. Okay, you've made your slope fraction, I guess I should say. Now, to help students set this up correctly, we're going to color code a little bit. So in my class, I had you guys use highlighters, and I said we're going to highlight the top of the fraction in one color. So let's go to all of our formulas where I've set this up. And I'm highlighting all the tops. Okay, so that represents y values. Well, which numbers are the y values? Okay, so the y values are always the second numbers. Okay, first numbers are always x's, the second numbers are always y's. So let's go ahead and label those as well. Okay. Then the bottom of the fraction is where I subtract the x values. Okay, so on the bottom, we're highlighting that in the other color. Highlighting this in the other color. And one more. Okay, which ones are the x values? The first numbers. Okay, feel free to use highlighters on your homework to help you set this up right. So setting this up, first we're subtracting our y's and x's. Sorry, it's between classes now. Alright, the bell is done. So the purpose of the color coding is to help you get the numbers in the right place. So in other words, I can only take our y values and I can only put those on top. So I'm making the color of the numbers match the color of the zone where they're going. Why? Because that's what the formula says. I can only put y values on top. Okay, y1 minus y2. The little 1 and the little 2 are like little name tags. They're not like an exponent in the wrong place. They're not operational. It just means that 6 is a y value, 9 is a y value, but they're not the same y value. So we put a 1 and a 2 to show that there's two different y values. Okay, now the 6 and the 9. Does not matter whether I do 6 take away 9 or 9 take away 6. So since it doesn't matter, I'm going to pick 9 take away 6 because that gives me an even or a positive answer on top. I get 3. Okay. However, once I have chosen my top value of 9, okay, I brought that over to here. That means when I place the 8 in its zone, it has to go underneath the 9. I don't have a choice. Even if I get a negative answer, I have to keep the same numbers. If they're in parentheses here, they have to be in parentheses in the slope formula together. So 6 and 4, 4 and 6, they are together. So they must be together in the fraction. Okay, so 9 take away 6 is 3, 8 take away 4 is 4. So I've set up with my x and y's by subbing in. Okay, I'm subtracting my y's, subtracting my x's to get 3 and 4. I'm going to look to see if I can reduce the fraction or simplify. 3/4 can't be simplified or reduced, so that one's done. Okay, the next one. Okay, so I have a y value of 6 and a y value of 4. I can do 6 take away 4. I can do 4 take away 6. Okay, it doesn't matter, but I prefer to get positives on at least for one number. Okay, what I'm avoiding here is the situation where both my top and my bottom are negatives. I'm trying to reduce how many negatives you get. All right, so 6 take away 4 means I don't get a negative. I get a 2. However, if I started off with 6 on the top, I have to put 1 first on the bottom. I have to put the 5 underneath the 4. Even though it means 1 take away 5 is going to be a negative 4. I can get negatives on the bottom. I can get negatives on the top too. Okay, but usually doing the larger y value, subtracting the smaller y value, can at least avoid getting one of the negatives. Okay, so this can be simplified. I'm going to take the negative sign and make it even with the fraction bar, and I'm going to rewrite that because that does not look very good. Okay, I want to space out my equal sign, my negative, and my fraction bar, and then 2/4 simplifies to 1/2. So the answer would be negative 1/2. So make sure you're simplifying if you can. Okay, last one. I can do 6 take away 9, or I can do 9 take away 6. So I'm going to choose 9 take away 6 to get 3 on top. But now I'm locked in. If I picked 9 first on the top, I have to choose negative 1 first on the bottom. And if I picked 6 second, I have to have negative 4 second. Now, we're getting into a lot of negative numbers and adding and subtracting, and you know, as much as I would want all of you to be fluent in adding and subtracting with positive and negative numbers, some of you are not, and please use a calculator. Okay, negative 1 subtract a negative 4 would be positive 3. Some of you also might know that subtracting a negative is the same thing as adding. So if I owe $1 and I get $4, then that's positive 3. You could type it in. Whatever you have to do to get a positive 3, that's what I want you to do. If it takes a calculator, use a calculator. Okay, so 3 over 3 reduces to 1 over 1, or just positive 1. Sometimes you'll want the fraction, sometimes you'll want the whole number. You'll have to see in future situations which one you want. Okay. On the homework. Okay. Let's say we were doing number 14. I highly encourage you to continue color coding. Draw yourself a long fraction bar with a subtract on top and a subtract on the bottom. Highlight your top in one color. Go to your values, highlight your y values in that same color. Highlight your bottom in another color, and highlight your x values in that same color. And now you can only put the number in the same color zone as you highlighted it. In other words, I have a 2 that I highlighted here in blue. I cannot put it in the yellow zone. We're color coding for a reason. I can only put 2 on the bottom. Okay? We don't even start on the bottom. We start on the top. Those are y values that I highlighted yellow. Okay? They are both 1. 1, take away 1s. Alright? Since they're the same, I guess it doesn't matter too much. But 2 and 3 are my x values. I can only put blue numbers on the bottom. 1 take away 1 is 0, and 2 take away 3 is -1. If I have a 0 on top, we say this is 0 slope. Okay, let's do number 15. Draw yourself a fraction bar with a subtraction sign and a subtraction sign. Let's again do our color coding. 4 and 10 are y values, and they go on top. 3 and 6 are x values, and they go on bottom. Okay, so I could do 4 and 10 are yellow. They can go on top. They're y values. 4 take away 10 or 10 take away 4. Well, 10 take away 4 gives us a positive number on top. So that's one less negative to worry about. Okay. However, if I put 10 first, that means I have to put 6 first. Okay. And 6 take away 3. The 3 has to stay underneath the 4. 6 take away 3 is 3. That simplifies to 2. Well, it could also simplify to 2 over 1, because I could divide the top and bottom by 3, but that's 2. Okay, so I highly encourage you to color code to help you put the numbers in the correct place in the formula. All right, have a great day. Thank you.